Australia once belonged to giants, not dinosaurs, but enormous marsupials, towering birds and reptiles that shared the continent with the first people. They lived during the Pleistocene, a long age of repeated ice cycles, shifting rainfall and landscapes that could change from woodland to dry grassland and desert. Megafauna simply means large animals. Australia still has big wildlife, but the lost fauna included creatures far heavier than almost anything living here today. The most famous was Diprotodon, the largest marsupial known from the fossil record. It looked loosely like a gigantic wombat, but belonged to its own extinct branch. A large adult could stretch roughly 3 meters from nose to rump and weigh more than 2 tons. Its huge body was supported by pillar-like limbs and broad feet. Its teeth and jaws identify a plant eater. Herds probably moved through open woodland and shrubland, searching for leaves, stems, and other vegetation as water and seasons changed. At Lake Callabonna in South Australia, mud preserved the remains of many Diprotodon. The fossils reveal animals that became trapped around a shrinking inland lake. Australia also held giant short-faced kangaroos. Procoptodon goelieath was the largest known, while related short-faced kangaroos came in a remarkable range of shapes and sizes. The biggest stood around 2 meters tall. Their shortened faces, deep jaws, and heavy chewing teeth were suited to browsing on tough leaves rather than grazing like many modern kangaroos. Some had a single enlarged toe on each foot and powerful forelimbs. Their skeletons show that the kangaroo body plan once included forms very different from those alive today. The dominant mammalian predator was Thylacoleo the marsupial lion. It was not a cat, but a highly specialized relative of plant-eating marsupials. Enlarged blade-like premolars formed powerful cutting edges, strong forelimbs, and a large claw on the thumb helped it seize prey, while its tail and hind limbs supported a muscular body. Fossils suggest it could climb at least when young, or when conditions allowed. It was probably an ambush hunter rather than a long-distance pursuit predator. Genyornis newtoni was a massive flightless bird, around 2 meters tall. Despite its size and long legs, it was not a giant emu, but part of a separate ancient bird family. Its deep beak and heavy body have produced debate about its diet, but current evidence points mainly towards plant food. Its eggs were also exceptionally large. On the ground prowled Varanus priscus, often called Megalania. It was the largest terrestrial lizard known, though estimates of its exact length and weight still vary. It belonged to the same broad group as goannas and Komodo dragons. Even conservative reconstructions make it several meters long, and one of Pleistocene Australia's most formidable predators. 1MB narracortensis was a large, non-venomous snake from an older lineage than modern pythons. It probably killed by constriction and waited near water or shelter for passing prey. These animals did not live in isolation. They shared rivers, woodlands, and plains with giant wombats, heavy browsing marsupials, emus, crocodiles, and many species that survive today. Much of this vanished world is known from fossil time capsules at Narracourt in South Australia. Caves preserved bones across hundreds of thousands of years. Openings acted as natural pitfall traps. Animals fell into darkness, while owls and other predators carried smaller prey into the caves. Layers of sediment then protected the remains. Narracourt and River Sleigh were placed on the World Heritage List in 1994 because together they preserve an exceptional record of Australia's changing mammal life. People reached the ancient continent of Sahul at least 50,000 years ago. For a time, humans and the last megafauna occupied the same continent. By roughly 40,000 years ago, most of Australia's giant land animals had disappeared. Dating is difficult, and not every species vanished at exactly the same time. The cause remains debated. Human hunting and changes to fire regimes are leading explanations, while increasing aridity, climate variability, and shrinking water sources also placed ecosystems under stress. The most realistic answer may involve interacting pressures rather than one simple event. Large, slow-breeding animals can decline rapidly when even small additional losses continue for generations. Researchers test these ideas using radiocarbon and uranium series, dating ancient environments, tooth, where eggshell chemistry cut marks, and the changing distribution of fossils. When the giants disappeared, Australia lost huge browsers, grazers, and predators. Their absence altered food webs, vegetation, and the movement of nutrients through the landscape. Their story is not separate from modern wildlife. Wombats, kangaroos, goannas, and flightless birds are living branches of a far richer evolutionary history. Australia's lost giants survive in bones, footprints, eggshell, and ancient sediment. Each new discovery sharpens the picture and sometimes overturns what seemed certain. They remind us that extinction can permanently reshape a continent. The landscapes remain, but the giants that once walked through them are gone.